In this video, we will learn to use the Bluesky statistics software, and we will learn some basic functionalities of this particular software. So first of all, we need to open a data set. So I'm going to click here on open, and we will work with the Titanic data set, and just navigate to the place where you have stored your data file and press open, and press OK. And here you can see that the data file has been loaded, and with this tab here showing the name of the file, which is Titanic. Now we know that this particular data set has 4 attributes: passenger class, gender, age, and fare, and based upon them the response variable is whether the passenger survived or not. So 1 shows that the passenger survived and 0 shows that they did not survive. So whenever you load a data set, the first thing to go and check is that you go to the variables tab here and make sure that the variables are of the appropriate class and type. Now we know that passenger class has to be a factor variable because there are 3 passenger classes, class 1, 2, and 3, but this here shows numeric because the software was not able to guess correctly from these values if they are numbers or if these are categories. So we need to convert this numeric to a factor, and the way we do that is by right-clicking here and then saying make factor. And then you see it recognizes those levels automatically, 1, 2, and 3. We know gender is already a factor, which it has picked correctly from the column male and female. Age is numeric, fare is numeric, and likewise survived should also be a factor variable because survived is 2 categories, 1 for survival and 0 for not survived. Now, having made those changes, we go back to the data set, and now we can see that all those variables which have a factor have these small little 3 bars with them, whereas those which are numeric variables have the numbers 1, 2, and 3 with them. So just by looking at the data, you're able to recognize if they are probably appropriate class, like numeric or factor or whatever. Okay, having done that, let's first of all do some basic analysis on these variables. So we will go to the analysis tab and we'll go to summary. And in summary, let's click descriptives, and we have all the variables on this side. Selected variables will appear on this side. Let's take age, for example, bring it here, and these are the options for numeric variables: min, max, mean, median, standard deviation, etc. Skewness, kurtosis, interquartile range. So you could select any of these. I'm going to leave them as a default right now, and I'm just going to click this button, execute dialog, and here is the statistics. Here is the statistics that I get for age. So we can see the mean age is 29.471, standard deviation is 14.122, and so on. So if you want to repeat the analysis, just click this button here and the same dialog is going to open once again, and then you can maybe change variables, take it back, bring in another one, and likewise perform your analysis for descriptive statistics. So that was the first thing that we wanted to look at, descriptive statistics. Let's quickly look at some graphs. So go to this tab here, graphics, and let's make a box plot, and let's make a box plot again for the variable age. So just bring Y here and then click this execute dialog button, and here we have the output and we have the box plot here. You can see some dots right here on the positive side, the higher side of age. So all these are outliers. Essentially that means that among the passengers there are some very old people, age maybe 70 plus. So all those have been flagged as outliers. Likewise, you could make let's say you could make a pie chart for gender if you want to see how the gender is distributed, and here is our pie chart. You can see females and males shown in different colors. So from this pie chart we can see that males are in majority on the ship. Likewise, we could repeat this pie chart for the variable survived, and you can see that 0 is in majority. So you could say from this pie chart conclude that majority of the passengers did not survive. Okay, so box plots, bar charts, line charts, pie charts, scatter plots. We have different options which you can select according to the kind of analysis that you need. The third thing that we are going to look at is how to build models. So in class we have studied simple linear regression, which is used to predict numeric variables. So in model fitting, you go to regression and then you choose linear basic. So the dependent variable, which has to be numeric, has to be brought here. The independent variables, they could be categorical as well, are going to be brought here in this part. And then when you're done, you just simply click the execute dialog button, and then the output in terms of regression coefficients and the equation will appear in the output section on the right side. So that is how you perform a simple linear regression, which could also be a multiple regression if you have multiple independent variables brought here. So what we will do now is we will fit a logistic regression model. So we again go back to model fitting, regression, and logistic basic. Choose the logistic basic option. Our dependent variable is survived, and we will take all other variables except fair as the independent variables. That's it. That's how you select the variables, and I'm going to press this execute dialog button, and the output will appear on this side. So you can see here is your logistic regression model. Here all the values have been placed. Now where did this 1.199 with p class 2 come from? If you look at the coefficients table with p class 2, the estimate coefficient is minus 1.199. So that is how it went up there. And accordingly, all these estimates find their place in the model, and this is your regression equation or the logistic regression model. Remember, we are trying to predict probability of survived equal to 1, means we are trying to predict survival. So that is the class of interest. Now we know how to interpret the logistic regression coefficients. We have done enough practice to do that. P class 1 doesn't appear in the output, which means that is the reference class. So you could say, as compared to those who were traveling in passenger class 1, the odds of survival of passenger class 2 are less. Why less? Because there is a minus sign here. And how less? Well, you know, e raised to power minus 1.199 will give you the factor with which you will multiply those odds, and then you will get the correct interpretation. Now, interestingly, Bluesky statistics software already calculates those odds for you and gives them in the table down below here, odds as odds ratio. So you can see P class 2 is 0.301. So these are the odds. What I'm trying to say is that e raised to power minus 1.199 is equal to 0.301. It has already calculated that. It has written that here. So now the interpretation is easy. As compared to passengers traveling in passenger class 1, the odds of survival of passenger class 2 will be multiplied by 0.301. So of course, the odds of these passengers are going to decrease because you are multiplying by something which is less than 1. Likewise, the same for passenger class 3 as well. The odds of survival of passenger class 3 are less than those of traveling in passenger class 1, as evident from here. And likewise, we know how to interpret the logistic regression coefficients. So if you want to repeat the analysis, simply click here, and then the lastly used model dialog button dialog box opens, and you can make some changes if you want. Also notice it gives a model name by default. Why it does that is that whatever model it makes, it stores them in its memory, and later on you can use logistic 1 in making predictions as well, and we will learn in a later video of how to do that. And this is the way of making predictive models using logistic regression and Bluesky statistics software. So in this short video, we have learned some basics of using the software, and we have learned how to do model fitting using regression, simple linear regression, multiple regression, which will have, of course, multiple independent variables, and logistic regression. So these 3 different methods have been covered in this particular video, and in the next one we will learn how to use the other modeling techniques that we have studied and are going to be used.